For the next part of the lecture, we will be considering functions involving the greatest integer sign. But first, let us recall the definition of the absolute value of x. The absolute value of x is equal to n for x between n and n plus 1, n included, n plus 1 excluded, where n is an integer. So in other words, the greatest integer function is a function that takes integers as its output. So in particular, the absolute value of x is equal to 0 when x is greater than or equal to 0 but less than 1. The greatest integer of x is equal to 1 if x is between 1 and 2, 1 included, 2 not included. And the greatest integer of x is equal to negative 1 if x is a value between negative 1 and 0, negative 1 included, 0 excluded, and so on. So, using this definition of the greatest integer of x, we can consider limits of the greatest integer of x. So for example, let us take the limit of the greatest integer of x as x tends to negative 2 from the left side. This means that we want to consider x values that are close to negative 2 but less than negative 2. So if we look at this piecewise function definition of the greatest integer function, we see that the interval that we need to consider is this interval here where x is between negative 3 and negative 2. And correspondingly, for this interval, the value of the greatest integer of x is equal to negative 3. For any value of x that is very, very close to negative 2 but less than negative 2, the functional value of the greatest integer function is negative 3. And so, if we want the limit of the greatest integer of x as x tends to negative 2 from the left side, this greatest integer of x here will be replaced with negative 3. And so we will have the limit of negative 3 as x tends to negative 2 from the left, which is equal to negative 3. So this limit here is equal to negative of 3. For the second example, let us consider the limit of the absolute value of x as x tends to negative 2 from the right side. This means that we are considering x values that are very, very close to negative 2 but are greater than negative 2. So here, we need to consider this interval of x values from negative 2 to negative 1. And we see that the corresponding functional value of the GIF of x is negative 2. And so, we could need to consider the limit of negative 2 as x tends to negative 2 from the right, which is equal to negative 2. So this limit here is equal to negative of 2. Now, for the third example, let us consider the limit of the GIF of x as x tends to 1/2. So here we need to consider x values that are very, very close to 1/2. So which interval of values are we going to use? Clearly, when x is very, very close to 1/2, that x is between 0 and 1. So we are looking at this interval here, and the corresponding functional value of the GIF of x is 0. And so we will have the limit of 0 as x tends to 1/2, which will give us 0. Now, for the next example, we will modify the expression inside the greatest integer sign. Right? So let us consider the function f of x, which is equal to the greatest integer of 2x minus 1. Now let us suppose that the greatest integer of 2x minus 1 is equal to n, where n is an integer. Now in this case, this means that 2x minus 1 is between n and n plus 1, where n is included and n plus 1 is not included. So let us solve for x in this sequence of inequalities. So first, we add the terms here by 1. So we increase the terms here by 1. So we will have n plus 1, and then 2x, and then n plus 2. And finally, to get the expression x, we need to divide everything by 2. And so we will have n plus 1 divided by 2 less than or equal to x less than n plus 2 over 2. So in particular, the GIF of 2x minus 1 is 0 precisely when x is between 0 plus 1 divided by 2 or 1/2 and 0 plus 2 divided by 2 or 1, where 1/2 is included and 1 is not included. Now, the GIF of 2x minus 1 is equal to 1 when x is between 1 plus 1 over 2 or 1 and 1 plus 2 over 2 or 3/2. And note that 1 is included while 3/2 is not included, and so on. Right? So, let us consider the three following limits here. So, in the first one, we take the limit of the function f as x tends to 1/2 from the left side. This means that x should be less than 1/2. So, when x is less than 1/2, this GIF here is equal to -1. And so for the first limit, we have -1 as the limit. For the second one, let us consider the limit of f as x tends to 1/2 from the right side. So this means that x is greater than 1/2. So looking at this definition here, x is greater than 1/2. That means that the GIF of 2x minus 1 is 0. And so, we have the limit of 0 as x tends to 1/2 from the right, or 0. So the second limit is equal to 0. Now, for the third limit, we want the limit of f as x tends to 1/4. Now note that when we consider x values that are very, very close to 1/4, we are looking at x values that are less than 1/2. And so, we replace the GIF of 2x minus 1 with -1. And so, evaluating the limit, we will get -1 as the limit of f as x tends to 1/4. Now, let us generalize. To evaluate limits involving the greatest integer of a function f of x, one may do the following. If the limit of the function f of x as x tends to a from the right or from the left is not an integer, we may replace the expression GIF of the function f by the GIF of the limit of f. On the other hand, if the limit of f of x is equal to some integer n, then there are two possibilities. First, if f of x is tending to n from the positive side, so n plus, we replace the GIF of f of x by n. On the other hand, if f of x tends to n from the negative side or n minus, then we replace the GIF of f of x by n minus 1. So let us consider some examples. First, let us find the limit of the GIF of -x over 5 as x tends to 5 from the positive side. Now, since x is tending 5 from the positive side, that means that negative x over 5 is tending negative 1 from the left side. Okay? Now, how to see this? Alright. So, when we plug in 5 here, note that we will have 5 divided by 5, which is equal to 1. Right? But the numerator is a positive number, rather, a number greater than 5. Right? So, we are dividing a positive number by 5, and we will get here 1, but there is a negative sign, so it's negative 1. So, we will have negative 1 from the left side. Alright? So, that means we are looking at numbers that are less than negative 1. Therefore, the expression, the GIF of negative x divided by 5, we should replace that by negative 1 and then we subtract 1. Since negative x over 5, the function inside the GIF sign is tending the number n from the left side. Alright? So, here we will have the limit of negative 1 minus 1 as x tends to 5 from the positive side is equal to negative 2. Now, let us consider the same expression, but this time, let's take the limit as x tends to 5 from the negative side, from the left side. Right? So, you may take, for example, the test point 4.999. Alright. Now, x is very, very close to 5. So, again, 5 over 5 will just be 1. So, this is negative 1. This expression inside here is tending to negative 1. Now, all we need to decide is it tending to negative 1 from the right side or from the left side? Now, let us recall that here, we want x to tend to 5 from the left side. So, we may take 4.9 as our test point. And so, when we have 4.9 divided by 5, what we get is a quotient that is very, very close to 1, but actually less than 1. Alright? So, we will have negative of a number very, very close to 1, but actually less than 1. And so, we will have negative 1 from the right side. Okay? So, what are numbers that are very, very close to negative 1, but greater than negative 1? For example, you may have negative 0.9 or negative 0.99. Right? So, in other words, our expression negative x over 5 is tending an integer from the positive side. And so, when we consider the limit of the GIF of this function, what we need to do is to replace the GIF by the number negative 1. Right? And so, the answer in this case is negative 1. Actually, another way of doing this is you can simply consider a test point for x that is very, very close to 5 from the left side. So, something like 4.99999. And you can compute this GIF and that will give you negative 1. Alright? Now, for the next example, let us find the limit of the same expression as x tends to negative 2 from the right side. So, note that when you plug in negative 2 to x here, what you will get is 2 divided by 5. 2 over 5 is not an integer. So, what do we do in this case? Right? Now, as x tends to negative 2, from the right side, negative x over 5 tends to 2 over 5, which is not an integer. So when we consider the limit of the GIF of negative x over 5, as x tends to negative 2 from the right side, what we will have is the limit of the GIF of 2 over 5 as x tends to negative 2 from the positive side. Now, what is the GIF of 2 over 5? 2 over 5 is a number between 0 and 1, so the GIF is 0. And so the limit is equal to 0. Okay, some other examples. So here, let us consider the GIF of 3x minus 1. Right? What is the limit of the GIF of 3x minus 1 as x tends to negative 1/3 from the positive side? First, let us plug in negative 1 over 3 to the x in this expression. So we will have 3 times negative 1/3 or negative 1 minus 1. So we will get negative 2, which is an integer. Alright? Now, we need to decide whether this negative 2 here is negative 2 plus or negative 2 minus. Alright? So, negative 1 over 3 plus, we need to consider numbers that are very, very close to negative 1 over 3 but greater than negative 1 over 3. So actually, when you compute for 3x minus 1 using numbers that are very, very close to negative 1/3 but greater than negative 1/3, what we will get is a number that is very, very close to negative 2 but greater than negative 2. And so, this expression here, the GIF of 3x minus 1, should be replaced with the integer negative 2. Okay? And so, finally, we will get the limit of negative 2 as x tends to negative 1/3 from the right side. This is a constant, so the limit is also negative 2. For the next example, let us consider the limit of 3x minus 1 as x tends to 2 from the negative side. So you may take some test points, which are points very, very close to 2 but less than 2, say 1.999. But before that, let us first plug in 2 to 3x minus 1. And what do we get? So 3 times 2 is 6, minus 1, 5. So is this 5 plus or 5 minus? Okay? Again, let us go back to our test point, 1.999. 3 times 1.999 is a number very, very close to 6 but less than 6. If we subtract 1 to that number, we'll get something that is very, very close to 5 but less than 5. And so, we have the GIF of 5 minus. And so, when we replace the GIF of this expression, 3x minus 1, we need to subtract 1 from the obtained integer. So, 5 minus 1 or 4. And so, the limit is equal to 4. And finally, let us consider the limit of the GIF of 3x minus 1. But this time, let us make x approach 3 halves. Okay? First, let us plug in 3 halves to x in 3x minus 1. So, 3 times 3 halves is 9 halves minus 1 will get 7 halves. 7 halves is not an integer. So, we just need to get the GIF of 7 halves. 7 halves is 3.5. So, the GIF is 3. So, the limit of 3 is equal to 3. So, this original limit here is equal to 3.